Okay, so what we're going to cover today is the difference between net area or net change and total area, total change. Okay, and it's very intuitive. Net area means you add up all the areas, and if they're positive, they're positive, they're negative, then you subtract. We've done this before, okay? And then total area means whatever area that's negative, whichever area that's negative, you're going to make that positive. And just set up all the areas as if they were all positive, because you want to see how much area was actually considered. Okay, so, and it's going to be the same thing for when you have velocity. We call that for net velocity, I guess you would call that displacement, and it's the integral from a to b of v of t dt. Okay, we call that the displacement, or net change. Net change is also good, but displacement will tell you where the particle ended up. Because remember, the integral of velocity is position, so after a certain amount of time, that information will give you where the particle ended up. But if you want to see how much the particle traveled, then that would be the total change, or total change, basically total change. And that's going to be the integral from a to b, absolute value of v of t dt. And that will give you the total distance traveled. Okay. Okay. So, or total change, total distance traveled. Now, this picture here, I wanted to illustrate the point about net area. So if your area is positive or your net area is negative, you would just add them up. So let's say this is A and this is B. We call this 0x1 and this 0x2. So it's important to know where the graph hits the x-axis. It's important to know the zeros, because both for displacement or total change, you're going to break up your area into a sum. So this is the integral from a to x1 of f of x dx. Let's say this is f of x, plus the integral from x1 to x2 of f of x dx, plus the integral from x2 to, let's call this, I missed one, x3, f of x dx, plus the integral from x3 to b of f of x dx. Okay, and that's it. You don't have to change any signs. You don't have to do anything like that. Okay. However, if you're asked for the total area, for the absolute value of all of this, then okay, it's basically the same thing. So go ahead and rewrite this. Take your time. Pause this video. Rewrite it. And everything that's negative, you're going to put an absolute value. So between x1 and x2, make that positive. Between x3 and b, make sure that's positive. That doesn't really help here. I should highlight it. So make sure this here is positive and this here is positive. Okay. So let's do some examples of where you have to do this. Notice, knowing the zeros is important. Okay, notice that. All right, next page. Let's say you want the net change and the total change. So let's do the net change. Just nothing to do, just to take the integral from -1 to 2 here of x cubed minus x squared minus 2x with respect to x. And this is just x to the 4 over 4th minus x cubed over 3 minus 2x squared over 2. That just ends up canceling. Okay, so then you just plug in and simplify, or not. You don't have to simplify. Remember, it's an AB test. You don't have to simplify. You can leave it all as fractions, but you're going to plug in -1 and 2. So this is 2 to the 4th, which is 16. You know what? You can leave this as 2 to the 4th over 4 minus 2 to the 3rd over 3 minus 2 squared. and then subtract negative 1 to the 4th over 4 minus negative 1 cubed over 3 minus negative 1 squared. You don't have to simplify that. Okay, you can leave it as this as long as you plug in everything. Once you plug in, you don't have to do arithmetic. You do have to evaluate, but you don't have to do arithmetic. Okay, not too bad. Net change, not much to do. Total change, however, for total change, well, where do we break up the integral? We don't know. Well, we need to figure out where the zeros are. So for total change, you need to find zeros first. Okay. Net change, nothing to do. You start right away. So let's do that. Let's find the zeros. So we have x cubed minus x squared minus 2x. Set that equal to 0. Maybe factor a little bit to make that easier for you. And that's x squared minus x minus 2 equals 0. Factor some more. And we get x equals 0, x equals 2, and x equals negative 1. Now we break up our integral. Okay, now we can break this up into, we can break up the integral from negative 1 to 2 of absolute value of x cubed minus x squared minus 2x dx. This is equal to the integral from negative 1 to 0 of x cubed minus x squared minus 2x dx plus the integral from 0 to 2 of the same function. And don't forget to put your absolute values. Okay. Okay, we already took the integral above, so we just have to plug in. So we have x to the 4th over 4 minus x cubed over 3 minus x squared, and we're going from negative 1 to 0. Okay, and you're going to take the absolute value of this, don't forget. And then same thing, plus and from 0 to 2, but don't forget to take the absolute value. Okay, you cannot leave it like this. You have to plug in. You can leave things as a sum and a you don't have to do arithmetic. You can leave things as a sum or a difference, but you do have to plug in. Okay, so we end up getting 0 minus 1/4 minus 1/3 minus plus 1, so plus I mean plus 1, and this is going to be positive, so I'm not going to do anything there. And then I have here 2 to 4 minus 8/3 minus 4 minus 0. Well, that cancels with that, and I'm going to take this 8/3 and make sure I make it positive. And then here I have 1 minus a 5. I know this is positive because this is less than 1, and then I have that 1 there. So this is 1, so this is minus 1/3, which I can combine with the 8/3, and then 1, and then minus 1/4. Again, you can leave it like this, but if you want to simplify, this is negative 3 over 12 plus 28 over 12 plus 12 over 12. I end up with 37 over 12. Not fun. It's okay to leave it. Actually, no, it's okay to leave it like this. Okay. All right, let's do a velocity one. Okay, so you're given velocity and you're asked for displacement and the total distance traveled. So displacement, you just take the integral from 1 to 11 of 3t squared minus 18t and dt with respect to time here. And you get 3t cubed over 3 minus 18t over 2, and we're going from 1 to 11. So this is just t cubed minus 9t squared, and plug in. So 11 cubed minus 9 times 11 squared minus 1 minus 9. You can leave it like this. Okay. However, if you simplify, you end up with 242 plus 8. You end up with 250. If this had units like feet or centimeters or something, you would add the units. Okay, so this is net or displacement. Displacement. Okay. Now let's look at total distance. Remember, for total distance, you need to find the zeros first. So we need to set 3t squared minus 18t equal to 0. Let's do a little factoring and then find our zeros. 0 and 6. Which means we need to break up this integral into the integral from 1, no, oh. So 0 is, I'm not going to use 0 because that's not in the interval. I'm going from 1 to 11. So I'm going to break this up into the integral from 1 to 6. And the integral from 6 to 11. And whatever I get, I need to make sure I take the absolute value. Okay. Another strategy is to look at 0 and 6 and then test v of t to see if it's going to be positive or negative before, in between, or after. So for example, because we're going from 1 to 11, so you really only need to test a number between 1 and 6 and 6 and 11. So if you plug in, for example, 2, what do you get? If you plug in 2 over here, you get 2 times negative, you end up with negative. So all of this is negative. And then to the right of 6, then that's going to be positive. So you know you only really need to worry about the numbers to the right here, the area to the right, the second area, and make sure that one is positive. So how would you do that? You would do that by subtracting something that's negative. Okay, that's another way of doing these types of problems. Some people like this, some people don't. Doesn't matter. So, okay, so we take the integral, we get t cubed minus 9t squared, and we're going from 1 to 6. And then we're going to subtract that negative area, which I test. Oops. No, this area was positive. We're going to subtract this area. So whatever this is, we're going to subtract it to make it positive, and then add this area here, because we found this to be positive, so we don't have to subtract it, but we found this area here to be negative, so we're going to subtract it to make it positive. Okay, so then we end up with same thing, t cubed minus 9t squared, and we're going from 6 to 11. So then you plug in, and I might like this better because then when you plug in, you can just leave it as the numbers plugged in. So that minus, when you plug in 1, you get negative 8. We did that before. And then plus, and we did this already, 242 minus negative 108. And you can leave it like this. It's fine. You can also simplify and end up with your answer. Okay, so that would normally be it for today, except I want to do an example from the homework. So we're going to do one more. So the last example is from the homework 2009.1, or example 3 in this foldable. So if you have your worksheet, just get that worksheet and look at the problem there. Okay. Okay, so it says Karen rides a bike along a straight road from home to school, starting at 0, ending at 12 minutes. During that time interval, her velocity in miles per minute is modeled by the piecewise linear function whose graph is shown above. Using correct units, explain the meaning of the integral from 0 to 12 of absolute value of v of t dt. So what does that mean? The integral from 0 to 12 of v of t dt is equal to the total distance traveled by Karen on her way to school. So the total distance traveled, what is it, in miles, give units, that Karen traveled from t equals 0 to t equals 12 minutes. Don't forget the units. Okay, find that. Well, the graph is up there. So the integral from 0 to 12, it means take all these areas and add them up. And because I'm looking at the total distance, not the net, whatever is negative, I need to make sure that to make that positive. Okay? So this is 2 times 0.2, which is 0.4, divided by 2 because 1/2 base times height. This is 0.2. And this is also 0.2. Yes, it's negative, but I'm going to make that positive. This is negative 0.2. I'm going to make that positive. Okay? And then up here, I have 1 times 0.3 divided by 2 is 0.15. And then I have 0.3 here. And then I have 0.25 here. And then here I have a 4 by 0.2, which is 4 by 0.2 is 0.8 divided by 2 is 0.4. And then here I have a 1 by 0.2 divided by 2 is 0.1. 4, 2, 0.8. Okay. This is 1.1. No, this is 0.5. My bad. This is 0.5. How could that be 0.5? Wait, this is 0.4. 4 times 0.2. 0.8 divided by 2 is 0.4. Yeah. So this should be, this is a 1 by 0.1 divided by 2 is 0.05. Jeez. Okay, so the area from 0 to 12 of v of t dt is equal to 0.2 plus 0.2 plus 0.05 plus the calculus is the easy part, guys. The decimals and fractions are always okay. Plus 0.3 plus 0.4 plus 0.1, and if you add that up, you end up with 1.8 miles. All right, that is it.